So in my last video here about ggplot and making graphs, I'm going to talk about line graphs. But my quick word on line graphs, I always think about line graphs as having a semi-continuous x-axis. So what does that mean? That means I may not have taken the data across time, but I am going to imply that it could be such a thing by using a line graph. For example, if you have exam scores, so exam 1, exam 2, exam 3, those are specific time points that you took. So you didn't take data continuously, but you're treating it as sort of a continuous learning across semester. Or let's say you're doing a dosage experiment, you have 0.2, 0.4, and that's like a semi-continuous x-axis. I think it's misleading to make a line graph of completely categorical data that doesn't have that continuity, because looking at a line graph implies continuity. So I'm actually going to make the one from the textbook, from the using statistics, or learning statistics using R field textbook, but as sort of a warning, like this graph could be misleading. So if you have, even though the data might be repeated measures, meaning that people are tested multiple times in multiple conditions, I would argue that line graphs should be reserved for times that you really are saying we're looking at this across this x-axis. And then anything that's truly categorical should be treated as a bar graph. Because if people read your methods section, they'll know that it's repeated measures. And I'm not saying that I have the right answer on this. I just feel that's my personal opinion, that line graphs really should imply some sort of continuity. And you'll see kind of why here in a second. I think that that's a thing. But that being said, line graphs are made in the same way as bar graphs. You'll see that the code is very, very similar. So instead of having a geom bar, we're going to add a geom point. And then instead of adding, instead of making those bar lines, we're going to separate them out into separate lines instead of separate bars. So we're going to start with this hiccup data, which I edited a little bit because it's so silly. But people have the hiccups, and so we're trying to cure the hiccups, and we're giving them, each of them, 4 different hiccup cures. So this is all repeated data. Every one is in every condition. Now, I'm going to show you how to work repeated data in ggplot and know that it can be applied to any other graph. So not really scatter plots, those need to stay as each of their own columns, but bar charts, box plots, if you're going to be working with repeated data, you can use this exact same procedure for each of those as well. Okay. So one problem with repeated data is that it's in wide format. So wide format is fine. That's how most of the time we get our data from the programs we use to collect it, like survey software, or if you're just entering the data, if you're a more traditional SPSS approach, where each person gets their own line. And so it's very easy to think about it in wide format here. So let me load the hiccup data, and I'll show you. So we're going to make line graphs now. So let's load the hiccup data. So I got my hiccup data, and all this data can be found on Andy Field's website, or the book website for his book. Oops. Okay, so here's something cool. If you forget to put the quotes, if you highlight everything and then hit the quotes, it will add them to it for you. Okay. So I've got my hiccup data. Go away, I don't know what that is. Okay. And then I told it to view the hiccup data. Okay. So here it is in wide format. Wide format means that each column is its own separate measurement, and each row is a person. Okay. But, sorry, just a second here. Go away, Excel. I don't want to do that. Instead, I want it to be in long format. Okay. And so that's the wrong format for ggplot. If you are, after this video, if you're struggling with wide versus long, go back and watch the video that includes the reshape function, because that's what we're about to use. Okay. So we're going to take all those scores and melt them into one column that includes the label for the DV and one column that includes the actual DV variable. So if you think about between subjects, traditionally those are listed with each IV gets its own column, so gender and handedness, and then the DV gets its own column. With repeated measures, it's often very confusing because each IV has a column and the DV is in the same column. So teaching with SPSS, I've always had to tell people like the names of the conditions are the labels, but then each column is excuse me, each column is the DV. If you put your data in log format, that makes it much simpler. I have a column for the IV, the labels of each condition, and a column for the DV, what do people score. So log format's actually a lot more intuitive, personally, if you've never been taught wide format. But either way, what we have to do is melt the data. So melt is part of the Reshape package. So let's use that. Okay, so I'm going to load up the Reshape library, or this won't work. Okay. And let's label this. Okay. And then let us make the data set. So I'm going to call this long hiccups so I know what it is. The code is melt. Okay. The first part of the melt function is the name of the data set, so hiccups. Okay. The second part is measured. So what are my measured variables? Actually, the second part is ID, but I don't have any ID variables. So if you look at the hiccups data set, I don't have a column that needs to stay the same. So the ID function in melt is all the columns that you want to stay, they're just going to get repeated. So this is generally between subjects variables and demographics and your other variables, maybe covariates. But I don't have one of those because this is all repeated, so I'm going to leave it out. So just FYI, that's why it's not there. I'm going to create, now I'm going to put in all my measured variables. Okay. So here's a trick real quick. What you can do is use the names function, and it will give me all the names of those columns, and I can cut and paste them into here. So those are the columns I want to melt, and I just have to add my commas. That is much faster than typing them all, especially if you can't spell like myself, or if you have a whole bunch of them. So I want to melt, and I'm going to take all these measured columns. So measure, think about measured as all the different measurements for your DV. So these are all our hiccup cures. So the DV is number of hiccups, but my IV is the different ways we've measured them. Okay. And so they have to be typed exactly the same, so you can use the names function to kind of hack that together. Now you'll get this little warning down here. It says using blank as ID variables because you didn't enter one. You don't have to have one, but it was kind of like, I was expecting IDs and you don't have them. Well, okay, I don't. So now if I look at the data set, I have each participant's baseline score and their value. Okay. Now this isn't the best way to make long data because generally you would want you would want some sort of ID variables. You might first add yourself in a participant number because if you're going to analyze repeated measures data in long format, you really have to know which line is for each participant. And so, excuse me, you would want to have that ID variable or participant number variable to be able to say this is participant 1 every single time. So when we get into multi-level modeling, that's really important because that tells it how to control for the error due to the fact that the participants are repeated. But we're just going to make a chart of the summary statistics. So I'm just kind of showing you the basics of this. But I do recommend always having a participant number column that you can use as an ID variable. And that's not too hard to add. Right, that being said, let's now make a line graph. Okay. So for this example, I have a single line graph because I don't have any between subjects variables to split the line graph on. And I'm going to go back to this real quick. So we melted the data. There's our new data set. And then the other issue is I need to make sure that my new column is factored out. Okay, so let's go back. It should be. So when you melt data, long hiccups here, it automatically makes this a factor, which is great. Because remember, our categorical stuff has to be a factor, and this is categorical in the sense that each condition is a separate thing. And then I have my value here. Now here's the real problem. Variable and value are quite possibly the worst labels to have because they don't mean anything. I mean, it should be IV and DV is what it's really saying, but I can make these names more mnemonic, okay, by using the column names function. So I could change them. Okay. If I do this here, it's going to change what my notes say. It won't quite match, but you'll get the idea. So that first column is actually intervention. Okay, so what type of intervention did we give them? And that second column is hiccups. Okay. Now, I can't get too crazy here because these are still the names that I would use to call the column, so no spaces. Don't add spaces. You'll regret your life later. Okay. So I can change those to something that's more memorable. Okay. All right. So let's make a line graph. Okay. And I'm going to just walk through all this stuff one little piece at a time, but here's the giant mess of code. So first thing we're going to do is create a blank graph. So I'm going to title this hiccup line. Ggplot. And now I'm going to use the dataset name, so long hiccups, my aesthetic function, AES. And so it has to be x-axis, y-axis. Well, I just relabeled my x-axis intervention. And then my y-axis here is hiccups. So that should have created us a blank graph. And there we go. So I got my blank graph. Now let's add things to it. So the first thing I'm going to add is this stat summary function. So stat summary is explained more in bar charts, but essentially when you have the entire data set, you have to first calculate the means to be able to graph them. So we're still graphing means here. And so you don't use that function as scatter plot because you want to graph each individual person. But if you give it the entire data set of each individual person and you want to graph the mean, you have to tell it to calculate the mean first. So that's what stat summary does. So I'm going to use the function of y. So what should I calculate on the y-axis? And I'm going to say calculate the mean for me. And then I have to tell it what to plot. So I'm going to plot points, point singular. So geom, now the previous video we talked about bar graphs, so geom was bar, but now I want to do geom is point. Okay. So let's make that graph real quick. Okay. So here's a very ugly, not complete at all line graph, right? Because I have the points for each piece now. Okay. So let's add the line to it. So plus here. Now to add the line, it's also stat summary. And so what I'm going to do here, sorry, I lost where I was in my notes. I'm going to calculate the mean as well. So function of y is still the mean. So it's the same line as before. Okay. But this time it's geom equals line. So give me a line between those points. Okay. And this piece is new. So I have to add this little aesthetic code here. And I have to say group equals 1. Okay. If you don't do that, it kind of has a fit for you, and it will tell you that you should add that code. So what that code does is it tells it that there's no grouping variable. This is a single line graph. So no grouping variable, group equals 1. And so it just kind of goes, oh, okay, there's nothing else to do. Okay. And then I could also color it if I want. So I could say the color is, I did red in the example. All right, and then I'm forgetting something here. And then we could also do line type. So this piece. These are just optional things. You don't actually have to do that, but I could do line type equals dashed. Go crazy. Okay, so let's run that. So now I have a red dashed line between them. Okay. If you left that out, you're going to get the defaults, which I believe is black and a solid line. So let's try it. Okay. So our default is a solid black line, which is actually probably what I'd want. But if you want to change it, it's color equals and then line type equals. All right, so now I've added the points. So this one adds points. Okay. This piece here adds the line. Now let's add the error bars. So it's another stat summary function, so your third stat summary for your day. And it's actually pretty much exactly the same as bar graphs. So function of the data, so calculate this from the data. It's mean CL normal. You can also use mean CL boot if you want. So you can use a normal distribution or a bootstrap distribution, and that is personal preference. That will give you the error bar. Geom equals error bar. And I can control the width. We aren't going to use the dodge function because we don't want it to dodge. We want it to be right on top of the point. So I'm not going to use dodge because I do want it to be right there overlapping. That adds us some error bars. Okay, so we got a lot of error at the top of our distribution for our baseline group because they're kind of all over the place. But then as we go through the different conditions, our other has the lowest with the smallest error. And that really gets back into models. So I know that the estimates for baseline are not necessarily the best because I have a wide range of data around that baseline. All right, let's clean this up some more. Let's add X and Y axis labels. Oop. Okay, spinny ball of death for a moment. So X and Y axis labels, or not. Not entirely sure what's going on here with Studio, but all right. So our X label here, this is going to be intervention type. And then our Y label, number of hiccups, because that's really what it is. Let's make a new graph. So now we have better X and Y axis labels. Remember, you can control the labels down here with scale X discrete, and you can look at that in the bar chart video. But the main thing I want to do here is clean up my graph. So I'm going to use my cleanup code. Since this is the last Ggplot video, woohoo! What I'm going to do here is show you what this is. Okay, so in all these videos I've talked about really making graphs APA style. This is for specifically psychology stats, but making these a journal appropriate because your advisor is just going to laugh at you if you send them in this graph with this gray background because these are not things that people print because they're not copyable. I mean, I don't know how much we like paper copy things anymore, but you want to have a professional looking graph. And so what I've done is I just searched how to get rid of that ugly gray background on Ggplot. And this, to me, gave me the most control. There is a theme black-white function that'll mostly clear all that out, but I like to have the power. So I found a website that gave me this example. So panel grid major will get rid of the grid lines, the bigger grid lines. Panel grid minor will get rid of the smaller white grid lines. Panel background gets rid of the white background, and axis line adds me an X and Y axis line, which is a much prettier graph than what we've got going here already. And so I have saved all of this code as the word cleanup because then I don't have to cut and paste it 1,000 times. So I can just add cleanup down here. And that saves me some space because this code's already pretty complicated. Let me do that. Ta-da! So this would be our cleaned up line graph. And you can make it red and purple and all that stuff. But here is back to my comment on line graphs. If I'm looking at this chart in someone's research paper, I'm assuming that they're talking about something over time because they have a line graph and it looks like, oh look, they got better, or the scores go down over time, and the variance actually goes down over time too. People get closer to the mean, and so we've got better estimates. But if I were to actually read this study and go, oh, they're just doing different hiccup cures, I mean, baseline clearly needs to be on the left here, but other than that, like, I don't know why they graphed it as a line graph. So this is just to show you how to make a line graph, because it's the example from the book, but I would probably argue that this should be a bar graph, which does not give you that sort of implied time with the little connector line between the two things, especially because they gave these in a randomized order. So there really is no reason why these three on this end have that 1, 2, 3 spot. Right? But if your field traditionally makes line graphs, make line graphs. I'm just telling you what we would normally do. All right, so the next thing I'm going to cover, and the last graph, woohoo, is a 2 independent variable graph. So how do I make a multi-line graph? So I'm using this data set that has kids that were either allowed to text or not, and then they were measured at baseline or 6 months. So to me, this variable, baseline versus 6 months, is semi-continuous. That is a time thing. So I really could use this as a line graph because it's over time. Okay. And then we gave them a % score on the grammar test. If you believe this text messaging is bad for language processing, I really recommend you watch John McWhorter's TED Talk on texting is killing language, JK. It is so great. It actually doesn't. It actually makes language better. It's really fascinating talk, but that's an aside because my research area is computational linguistics, so I find this really interesting. But anyway, so we're going to take this data set and create a multi-line graph. So the first thing I have to do is load the data. So we're going to work on a multi-line graph. And let me load up that data. So I called it texting. It's got my texting data loaded here. Now, the first problem I have is that that group variable came through with nothing. So I've got to make sure that that variable is factored before I start. So let me fix that. So I'm going to use the factor function. So the way the factor function works is the first thing you type is the column you want to fix. Okay, then the next piece that you type is the levels that you want to use. So I got two levels. And then what do you want to call those levels? So we've got texting allowed. So these are labels for the levels, so I could use spaces without having too much trouble. And no texting. So let me run that and create a group variable. So if I created a little table of my group variable here, now it's a factor variable. So that is much better for me because then I can use it as a grouping variable and it Ggplot won't freak out unless I do something else wrong, which is highly likely. Okay. Here's the next problem. This data, if you look at it, is in wide format. So the first thing I have to do is fix the grouping problem. Now we've got to melt the data and make it into long format. Okay, because this is a repeated measures design, if you're going to make a graph of the repeated component, bar graphs or line graphs or box plots, you have to melt the data. If you're going to make a scatter plot, you want to leave them as two separate columns because then you have an X and a Y. So we've got to melt first here. All right. So I'm going to make a long texting one and use the melt function. Okay. So what I want to do, oh, don't do that, go away. First thing you want to list in your melt function is the name of the data set. And then I do have an ID variable this time. So the ID variable is the between subjects or demographics or just the columns you don't want to change. And then I need to put in my measured variables. So my measured variables are my repeated measures pieces. And then that should do me good. So let's look at my long data set now. So I have my texting allowed participant, baseline, and their value. And then down here I have my texting allowed participant, their 6 month, and that value. I still would argue you probably need a participant number. But what it's basically done is it's taken those two 6 month and baseline columns and sort of stacked them on top of each other like you might do in Excel. I still have a really big issue with this being called variable and value. Those are not useful names. So I'm going to rename them using the call names function. Okay, so column names, dataset name, and then you just tell it what you want to use. So I got group, what group they're in. I have what time they're measured at. And then I have their grammar score. Okay. If I could learn to type today. Remember, these are the names of the columns here. So don't use spaces because otherwise, like I said, you'll regret your choices. It's hard to call variables that have names with spaces in them. So just as a general rule, don't label them with spaces and don't start with a number. So now I have much more mnemonic names. So now we can actually get into making the plot. So let's make ourselves a line graph. So we're going to use Ggplot. Name of the data set, long texting, because I had to melt the data. My aesthetic function. So I got my x-axis, time, my y-axis, grammar score, and then my color. So I want to separate these out by color, and I'm going to call it group. Okay. So we're going to use color here because these are line graphs. And so remember, color is for dots and lines lines around the bar. Fill is for bar graphs and confidence interval demands. Okay. You could also do fill here, but you wouldn't use it. So that should have created us a blank plot. Okay. So there we go. Now let's add things to our plot. So the first thing I want to add to the plot is very similar to above. So a stat summary. So let's get those dots in there. So the function of y is the mean. The geom type is point, because we're doing a line graph. So that should give me a pretty ugly graph, right? So I've got my texting allowed, my no texting allowed, and then my double dots here. I want to then add the lines. Okay, so I did points first, now let's add the lines. So it's still a function of y equals the mean. My geom equals line this time. Now the aesthetic component tells me who the group is. So my group equals the group. Now that's a little confusing, but what I'm basically saying is that my group here, where are we at here, is this grouping factor here. So group lowercase equals the name of the column with the variable you want to split on. So group equals group. So let's add the lines. Okay, so now my lines, look at the big difference here. So it says that if they were allowed to text, they got much worse. Because that's what people think happens. Okay. So now let's add confidence intervals. So our error bars. So function of the data equals mean CL. Now let's do boot this time. So we'll do bootstrapped confidence intervals. Geom equals error bar. So give me some error bar lines. And then let's give them a width, otherwise they look a little nuts. 0.2. I'm going to add that. You don't have to run this every single time. You could type the whole thing and run it once. I'm just trying to show you as I go what we're doing. So look at those confidence intervals. They overlap quite a lot. Okay. So what do I want to add now? Let's clean this up. So X labels. So my X label is actually pretty mnemonic, but I might say measurement time just to show you how it works. A Y label. Mean grammar score, because that's what it is. Okay, so I have much better X and Y labels now. And let's clean up this graph using our cleanup code. Ta-da! All right, now we're doing pretty good. What if I wanted to change the legend information? So let's do scale color, this time manual, because we're going to change the color of everything that's going on here. Okay. And I could do, let's see, so for scale color manual, remember I can change the name of it. So I want the name to be texting option. Okay. I could change, go away, the labels. My labels are actually pretty good, but this is how you change them. So just to be silly here for a second. Then I could also change, now I have to include values when you do this. So this is going to change the color of the lines. Okay. Let's do black and gray. So you can spell gray, English, American English or British English, by the way. Okay. So that changed the color of the two lines, so I could make it black and white because most journals want things in black and white or they make you pay a crazy fee. But what that didn't do is it didn't change the background of the legend label, which is really annoying. Okay. And so I could use a legend key function. Okay. But that's also controlled by the fill function. So I could do scale fill manual as well and turn both of them to white. But I'm going to just show you one more piece. So this is part of the theme coding, so I could add it to my cleanup function, but it's legend.key equals element rect for rectangles, okay, fill equals white. Okay. And that should, if all goes to plan, turn off the gray background here that makes that hard to read. Okay. And so that gave me a clean legend with no filling. You can do that on the other charts too, but often you want the fill because it's telling you what color the bar is. But in this case, since it's a line graph, I don't want it to fill anything in. Okay, so that's a different way other than using scale fill manual, which is one of the things I described in the scatter plots video. So that's how I could make myself a split level line graph. So I've split by another separate variable. And I, in this case, think it's a pretty appropriate use of a line graph. So you'll see that grammar is going down over time. I don't know that that's a significant difference. And this group is losing a lot faster than the other group, even though their error bars overlap. So that is how you create line graphs using Ggplot, and you're able to change all the different pieces of code. So make sure we didn't miss anything over here. This just goes through all the code we typed. Perfect. Okay, so now you know how to make a line graph in Ggplot.